record-breaking cyclone activity, explosive volcanic eruptions, powerful earthquakes, and endless heat waves. 2015 was marked by a number of exceptional natural disasters. The toll of these terrifying events, 20,000 lives lost, and more than $42 billion worth of damage. 2015 was a record-breaking year in several categories. Tropical storms of unprecedented strength, interminable droughts, and the highest temperatures measured in the last 130 years. Is this the result of global warming, or could other factors, such as El Niño, be to blame? How do scientists try to forecast these cataclysms? Is it possible for inhabitants to anticipate and prepare for these natural events? From the mountain range of the Andes to the Himalayan plateaus, past the frozen wastelands of Iceland and the Paradise Islands of Vanuatu, scientists try to unravel the mysteries of the planet's mood swings. Using only professionally shot footage, capturing the heart of the action, this film presents the major natural disasters of 2015, from the least deadly to the most dramatic. Typhoon Dejuan was emblematic of natural disasters for 2015, which hit Taiwan in September. 500 millimeters of rain, the equivalent of 4 months of precipitation, fell within 24 hours. Taiwan sits directly in the Pacific cyclone path, and the Taiwanese government is used to warning the population to stay indoors and evacuating areas that are most at risk. According to Fabrice Chauvin, cyclone specialist at Météo France, the official French weather forecaster, the island of Taiwan is closely monitored by the scientific community.
Taiwan is in a zone that is often hit by cyclones. The west of the North Pacific is the zone that has the most tropical cyclones. Out of all the cyclones, they receive about 60% of the year's cyclones.
The impact of the storm was particularly visible on the coast. The shoreline was devastated by huge waves that were the result of two events: the typhoon itself and the closeness of the Earth to the moon, which generated a storm surge.
The level of the sea rises because of the depression caused by the cyclone. Because there is less pressure on the sea finds its balance a bit higher than normal. So we have a rise in sea level.
In response to the emergency, the floodgates of dams were opened to compensate for the sudden influx of rainwater. This huge rainfall is due to surface sea temperatures being abnormally warm. This stimulates the number and intensity of North Pacific cyclones. A total of 29 have had wind speeds higher than 180 kilometers per hour in 2015. This unusual activity sets a record for the year to date. So many cyclones raged over the Pacific Ocean that this film shows a mere sample of these extreme weather events. It's 6 p.m., the end of the day in the tourist region of the Great Lakes, 50 kilometers from the town of Puerto Montt. In this peaceful area, residents suddenly hear sounds coming from underground. A mysterious rumbling rolls over the foothills of the Andes. No other warning, no other signs of alarm. Just 15 minutes after the first sounds are heard, the Calbuco volcano, dormant for 4 decades, sends a plume of thick smoke into the air.
There was very little precursory activity at Calbuco. The Chilean had a station close by, and just 1 hour before the eruption, they observed a signal that was interpreted to detect a magma coming up through the volcano.
The entire Andes mountain range is a highly active volcanic area. It's in a subduction zone, where one continental plate is forced under another.
When the subduction zone is going down, it goes through transformation, and all the seawater is pressed out, will enter into the mantle and lower the solidus, so the magma comes up.
This column of ash is a result of high-pressure gases trapped in the magma inside the volcano's reservoir. As the gases are forced out, they lose pressure and swell, taking with them small particles of lava. The plume is unusually high, rising 20 kilometers above the surface of the Earth, between the troposphere and the stratosphere. If the column of ash were to collapse onto the town of Puerto Montt and its 220,000 inhabitants, the results would be devastating.
You have a thrust coming up, and it's diluted in contact with the atmosphere, so you form a kind of a mushroom shape on the top. And when this is no longer sustainable, it will fall down, and you can form a pyroclastic flows that will fill the lows, the valleys, etc., and can flow very hot material and be very devastating.
Fortunately, the wind from the Pacific picks up, pushing the plume to the east where the mountains are unpopulated. The ash spreads to Argentina, where the authorities are forced to close the airspace. The ash is a dire threat to aircraft engines.
Very small particles, less than 10 micrometer in size, are not very healthy to breathe, because they have sharp edges and they can cut a little bit of your interior.
Puerto Montt is spared, for the moment. As a precaution, a 20-kilometer zone around the volcano is evacuated. After a period of calm, as night falls, there is a second explosion. The eruption enters a new phase, with electrostatic charges or volcanic lightning bolts exploding above Calbuco's crater.
Afterwards, there were bolts of lightning. They were really low. It was an incredible cloud. We could see it in the middle of the night, really close by. A cloud of sand arrived. It was very thick. We thought it was hailstones falling.
Though the eruption lasts 3 days and nights, no human lives are lost. The surrounding countryside, however, is destroyed. 210 million cubic meters of ash smother houses, forests, rivers, and plains.
The next day, I was one of the first to arrive in the area to see what it was like, and I found the restaurant like this, completely flattened. The entire restaurant is lost. I was born here and grew up here, and I would like to keep working here. It's just an accident of nature. It could happen here or anywhere. It's destiny.
Our garage collapsed, and the roof of an older house broke and twisted. We tried in vain to get fuel and food for the dogs because we didn't bring anything with us. And we only managed to get back into our house the next day to see what damage had been done.
The lava ejected from the volcano caused little remaining damage within the 5-kilometer perimeter. The real threat came from the tons of ash that accumulated on the roofs of buildings, which could have collapsed at any moment. 6,000 people were evacuated in order to avoid the risk of being trapped.
Here, there is about a meter of ash that has fallen. That's what we're trying to remove at the moment. This is also a tourist area, so there will be an economic impact. Regarding the farms, it looks like the ash will be a major problem for the livestock.
You may have volcanic gases coming along if they are very rich in fluorine, and this fluorine can stick to the surface of the ash grains. And if the animals eat a lot of the fluorine, they will lose their teeth and their bones.
But the main thing is the roofs of houses collapsing and pollution of water sources.
Not a drop of drinking water remains. Ash and sulfur contaminate all the rivers. In some areas, the layer of volcanic debris is so thick that the water is no longer even visible.
We have 4 days until Wednesday, when it is due to rain. So we need to have finished the houses that are in this state before then.
Rain is not to be taken lightly in this area of Chile, where clouds loaded with water from the Pacific Ocean are blocked by the Andes and release their charge in violent storms, causing landslides of mud and ash. Several months after the events, with the benefit of hindsight, volcanologists play down the effects of the Calbuco eruption.
Then there was a small eruption, well, important for those living close to the volcano, but small. The volume is being estimated. Maybe it's around 0.1 cubic kilometers, not much more than that, I presume.
Although the Chilean volcano took no human lives, it nevertheless caused $600 million of damage. The calamity that spared the Chileans hit the residents of another volcanic area. 5 years ago, after 400 years of inactivity, the Sinabung volcano awoke. Since then, its eruptions have been both regular and dramatic. The last one took place in June 2015. Usually, Sinabung's lava is thick and flows slowly. But this time, the volcano generated impressive pyroclastic flows. These are thick clouds of ash and lava particles that rise up and then collapse under their own weight, sweeping down the flanks of the volcano. 11,000 people were evacuated and moved this year. A catastrophe for the farmers, who could no longer access their land and resources for several months. Even though the volcano appeared to be calm, one person was killed when he breached the restricted area. Pyroclastic flows are difficult to predict and can extend up to 4 kilometers around the crater, with a cost of $145 million in agricultural damages. The 2015 cyclone season was particularly brutal in the Pacific. The main culprit is the return of El Niño, a weather phenomenon that appears on average every 3 to 7 years. El Niño is carefully monitored by long-term forecasters like Jacques Richon, who works on the 3-month forecast of Météo France.
Il s'agit d'une anomalie de la température de surface de
This is an anomaly that concerns the temperature of the surface water in the Pacific Ocean. The dominant winds in the Pacific are the trade winds, which push the warm surface water to the west. And then you have the situation with El Niño, where we see that the red zones move to the middle and the east of the Pacific, with the highest temperatures around 26 to 30 degrees, much further to the east. And in the atmosphere, above this warm water, there are very violent storms, vertical movement is much stronger, and precipitation is much stronger.
Not all El Niño events are alike, and this year, a particularly strong effect has been announced.
On est parti pour avoir un El Niño fort.
We're heading for another strong El Niño, one of the strongest in the last 50 years. We don't know yet if it's going to be a record breaker, but it's definitely strong this year.
A classic El Niño won't raise the temperature more than 1.5 degrees. The 97-98 El Niño rose to 2.3 or 2.5 degrees, depending on the area. Today, we are at 2 degrees, and we haven't yet reached the maximum.
The result is an exceptional cyclone season in the Pacific. Whether hurricanes, cyclones, or typhoons, the names change depending on where they take place. These spiraling storms have beaten several records in 2015.
In tropical storms, as soon as the wind speed is higher than 120 kilometers an hour, 74 miles an hour, they are categorized as cyclones. Below that is a tropical storm, and below that is a tropical depression. So in general, we take the forecast into account once it goes above tropical depression. We start to be very vigilant, and when it reaches tropical storm speed at 60 kilometers an hour, 37 miles an hour, we give it a name which allows us to follow it more easily.
El Niño is characterized by an abnormal rise in the temperature of the surface of the water in the East Pacific Ocean, a vital factor in the formation of one of the most sensational events of 2015, Hurricane Patricia. In October, the effects of El Niño began to make themselves felt. According to Eric Giliardi, climatologist and specialist of the Pacific Ocean, the water was warmer than is normal at this time of the year by 2 degrees Celsius.
This is a zone where there are some cyclones, but not very strong, and they certainly don't develop to the same size as Patricia. Patricia is directly linked to the fact that we have an El Niño at the moment. The fact that the water is warm in the east and stays warm is a source of energy for the hurricane, allowing it to develop. The source, the seeds of a hurricane, are always there, but the fact that it develops into a real hurricane of the size of Patricia is linked to atmospheric and oceanic conditions that are conducive to development.
With these unusual conditions, a remarkable phenomenon occurs. Hurricane Patricia rapidly intensifies. In only 24 hours, it morphs from a tropical storm to a Category 5 hurricane.
Theoretically, any hurricane could grow to maximum strength, like Hurricane Patricia. But in general, with hurricanes, there are other factors which will limit its amplification. The water gets a bit colder, it reaches a landmass, or there are high-altitude winds that destabilize the hurricane. When we look at the particular conditions of this hurricane, it really grew. There was nothing to prevent it from building to its theoretical maximum intensity.
On October 23rd, Hurricane Patricia slammed into Central America, breaking the wind speed record for the North Pacific with an incredible 265 kilometers per hour. The violence of the storm caused multiple casualties. 12 people died in landslides caused by torrential rain or by falling trees. Luckily, the hurricane's path missed the largest cities on the Mexican coast. The authorities had safety measures in place prepared to house 260,000 people, but ultimately only 50,000 were evacuated. Hurricane Patricia headed inland towards the mountains, rapidly losing power. The total cost of the damages was estimated at $5 billion. The economic evaluation of natural disasters varies depending upon the countries in which they take place.
The problem with looking at it worldwide is that the most expensive catastrophes happen in the richest countries. So, worldwide, the U.S., because of the wealth in the U.S., if you have a hurricane, the same size hurricane in the U.S. will cause far more cost than a storm, the same storm in China, for example. So simply because there's much more of value, there's much more wealth in the path of the storm.
Kopu is a good example of the math involved in natural disasters. When it hit the Philippines, it became the deadliest typhoon of 2015. Winds up to 210 kilometers per hour were recorded. Vast plains of rice fields were submerged by flooding due to rain and gigantic waves. 47 people died in the Philippines, 4 times more than in Mexico during Hurricane Patricia. Yet the cost of the damage in this developing country was 20 times lower than in North America, only $231 million. To understand the intensity of this typhoon, we need to look once again at El Niño, even though this anomaly concerns the East Pacific rather than the West.
The warm water moves to the east, but the water in the west stays warm. So this water is going to stay warm enough that hurricanes can develop. In fact, it's more like the area is extended during an El Niño rather than the area moving. The zone in which hurricanes can develop spreads out, so there are more hurricanes.
El Niño is a phenomenon that matured in the second half of 2015. So it cannot be held responsible for the entire year's weather-related natural disasters. What would happen if global warming combined with a strong El Niño? Would the effects of the two phenomena multiply? So far, scientists are unable to tell, but numerous studies are underway.
Global warming amplifies, not just for El Niño, but for everything, the whole planet. It amplifies existing natural phenomena. This is a combination of global warming and El Niño. We have seen that El Niño affects a quarter of the surface of our planet. So when El Niño warms by 1 degree, the global temperature rises by 0.1 degrees.
When it comes to climatic disruption, there are other, more mysterious and less known events than El Niño and global warming. And this year, their impact was significant. One of the longest-lasting and most expensive natural disasters in 2015 took place in California, where a period of drought has been ongoing for several years. And this summer, the situation is dire. The landscape is scorched. Water levels are at their lowest point, and the sun keeps shining. A highly inflammable combination that rages through the region's forests. Every year, forest fires hit the southwestern states, but in 2015, they reach epic proportions. Fires start spontaneously in 4 different areas of California, as well as in Washington, Oregon, Utah, and Montana. As many as 30 fires burn simultaneously at the height of summer, mobilizing 11,000 firemen from all over the country.
It was dry before simply because you had blocking weather systems which were preventing the storms actually coming into California in the winter, because the rainfall in California is almost entirely in the winter, and actually over the last few years there's been the weather patterns have prevented the storms coming in.
The blame for the drought lies with a relatively unknown weather phenomena, Pacific Decadal Oscillation. It's characterized by abnormally cool surface waters in the Pacific, which push warm waters to the north and south.
El Niño, c'est un phénomène qui revient de manière épisodique.
El Niño is a phenomenon that we see every 2 to 7 years. This is a phenomenon which oscillates over decades and which brings a positive temperature anomaly to the coast of North America. On this diagram, we can see the temperature anomalies caused by El Niño. And we also have an anomaly on the coasts, which is a phenomenon on a much longer scale, on a scale over decades, which started at the beginning of 2014. If the drought is caused by a large-scale climatic phenomenon, it's the combination of this and the El Niño which is developing.
The Pacific Decadal Oscillation has a cycle of around 20 to 30 years, and its interaction with El Niño is still not fully understood. Scientists can only state that these large-scale climatic occurrences sometimes combine, as they have in 2015.
In fact, it's a good illustration all over the planet. There are these variations of different frequencies. There is the diurnal cycle, night and day, and then we have the weather, the seasons, and now we have El Niño. Everywhere on the planet there are these variations, which we're learning more and more about. We have, on one hand, global warming, which is ongoing, and on the other hand, California, with a Mediterranean-type climate and very little rainfall. The projection for the future is that if we don't do anything, there will be less and less water. On top of that, we can add this decadal variation with fairly warm water off the coast of California, which has been there for several years and which reduces rainfall in this area. And now we have El Niño, which, on the contrary, is going to bring more rain.
The Pacific Decadal Oscillation will continue for several years, but its repercussions will lessen as the effects of El Niño increase.
This winter, there's a prediction that actually it's going to be very wet in California, and maybe that will break the drought. It's not clear if even one wet winter will restore the water levels, but it's widely expected that it's going to be very wet in California this winter.
The damage caused by these forest fires is catastrophic. It's the worst dry season in the last decade in the United States. Fires have consumed 31,600 square kilometers of land in the Southwest, the equivalent of the entire state of Maryland, burnt to a crisp in a few months. 6 people, including 2 firemen, lost their lives. 17,000 residents had to be moved to avoid being trapped by the fires. Financial loss is estimated at $3 billion, a heavy toll even for these wealthy states. In recent history, the wrath of the skies has been relatively benign compared to that of the Earth. 2015 continues this trend. Hemmed in between India and China lies Nepal. A small mountainous country the size of the state of Iowa, but 10 times more populated. 30 million souls, mostly Hindus, live in this landlocked country, including 1 million in the capital, Kathmandu. Nepal is one of the 10 poorest countries in the world. A third of its population live in rural areas, at least 2 hours' walk from the nearest permanent road, and rely on natural resources and the cultivation of rice to survive. In the mountainous regions, there are few trees left to retain the stones that perch above the villages, bustling with small shops. According to the Hindu religion, the Nepalese people celebrate in their ancient temples the rhythm of the earth, an endless succession of periods of creation, preservation, and dissolution. Science backs them up. Geologists like Jan Klinger look back at Nepal's tectonic origins.
The tectonic plates in this region mean that India rises up at a speed of 4 centimeters per year. The plates that make up the Earth's crust are stuck. They become deformed over a time, and when the 2 plates move together, The upper plate, the Eurasian plate, deforms and creates chains of mountains. We squeeze the Earth's crust and create landforms. In fact, these two plates rub together. They're stuck. So while it's pushing behind, here it's stuck, and that builds up until the crust goes beyond its limit of resistance and releases, producing an earthquake, which allows the tension, the energy in the plates to be released, and this produces an earthquake.
The last major earthquake in Nepal was back in 1934 and reached 8.3 on the Richter scale. In 2014, Jan Klinger published a study that suggested that the 1934 event was a warning of another imminent earthquake at this fault line. History would prove him right. On the 25th of April 2015, a 7.9 magnitude earthquake hit Nepal.
If I put that much energy into the system, a 7 or 8 magnitude earthquake will release about the same amount. So today, where have we released? Which zones have been released? Which zones don't need to be released as much? By doing this work, we're able to pinpoint the zone that broke as one of the zones that was susceptible to breaking.
Jean-Louis Munier is also a geologist. He traveled to Nepal just after the earthquake to install GPS receivers that would measure any new movements of the ground.
Some areas of the Himalayas, like the area to the north of Kathmandu, rose up by almost a meter in the space of a minute, because the earthquake lasted for about a minute. In other areas, paradoxically, the Himalayas sank down. For instance, some of the highest summits in the Himalayas sank down slightly for a moment.
The number of deaths directly caused by the earthquake is estimated at over 8,000. Although geologists had foreseen the possibility of an earthquake, it was nonetheless impossible to predict its arrival with any precision.
The way we work is that we look at historical earthquakes. We try to understand the size of those quakes in terms of destruction. Catastrophic earthquakes higher than a magnitude of 8 come about every few hundred years, between 700 and 800. And above that, you have the quakes that are only partial and which are added to the cycle.
Qui, eux, reviennent par-dessus ce cycle.
Above the epicenter, stone villages are completely destroyed by the shock wave, killing hundreds of people. The survivors are left homeless.
Hello, my name is Kenji Galung. I'm 12 years old, and I've lost everything. My house, and even my school.
When the earth shook, I was getting ready for the full moon festival. I was heating up some rice wine with myrrh that we call rekshi, just as I am now. Around me in the village, everything burned. Everything collapsed. We were afraid of aftershocks, so we went into the fields. After the earthquake, we spent 3 days in the fields with the animals with nothing to eat. Luckily, friends from other villages arrived with clothes and food. Today we have nothing, but we still need to carry on living. Now we live up here in the fields in an encampment of tents that we built quickly using tarpaulins. But these are not our real houses. Tomorrow, we don't know where we will live.
The 2015 earthquake was a catastrophe for Nepal, but at the same time, it happened on a Saturday, on a beautiful day at the end of the morning. So the rural population was out in the fields, the children weren't at school, they were playing outside. So the destruction was not hugely catastrophic in terms of loss of human life. If the earthquake had happened in the middle of the night or when the children were at school, it would have been much more catastrophic.
In the following days, dozens of aftershocks continued to shake Nepal, including one strong tremor measuring a whopping 7.3 on the Richter scale. And then another threat looms over the villages, the arrival of the monsoons. Heavy rains pound the stricken country. Water is inexorably drawn down into the earth. While it runs on the surface, it washes away the ground and turns roads to mud. But when the rainwater pours into the open wounds created by the earthquake, landslides are inevitable. And in Nepal, whole sides of mountains collapse.
So, just before the monsoon, the bowl has been shaken. So you have a number of slopes that are unstable, and when you add water to that, the ground gets heavier, and fissures are going to open up because you have put water in them. So you're going to create landslides that probably would have happened at some point, but over a longer period of time.
During the monsoon, you have a massive runoff from the Himalayas, several meters. There's a huge amount of water falling on the Himalayas, which creates small quakes. Little tremors that are nothing like the same magnitude as the major Himalayan earthquakes.
This village was literally swept away by a landslide and submerged under a flow of mud. 24 more victims are added to the number killed by the earthquake.
That was my house. The rain swept everything away. At 1 o'clock in the morning, it was raining really hard, and the land slipped. Then the landslide took down 13 houses. A group of 25 people tried to help someone whose house had been buried, but they couldn't get in.
There is no rest for the villagers. The monsoon season is the busiest time for farmers, tending the fields, the animals, and the crops that have survived. Further down the valley, Nepal's highly populated capital city was also severely shaken. Here, 1 million people live above the clay deposits left behind by a prehistoric lake. The seismic waves amplify as they cross the boundary between hard rock and soft ground. Traditional houses built of stone or brick are unable to survive the quake. Only recent constructions made of reinforced concrete still stand, and only where the steel is still holding the walls and floors together. Otherwise, the lower floors that support the weight of the building collapse.
If you go to Nepal, I just went afterwards. Not all the houses had fallen to the ground, far from it. But all the houses had been severely damaged and at the risk of collapsing. In any case, they are no longer habitable. They don't collapse during the earthquake, but they crack and break, and it just takes one slight thing to make them collapse.
In all, the earthquake caused 9,000 deaths and $10 billion of damage, half the country's gross domestic product, an exorbitant cost for Nepal. In order to find survivors, rescuers risk their lives. They excavate under floors that could collapse at any moment. By intervening quickly, emergency workers saved hundreds of lives.
It's extremely difficult to say it in words. Right? I was standing outside my gate when it happened. And the first shake was from the west heading to the east. My gate was swinging at least 3 feet to the east and west because my wife, my kid, and my mother were inside the house. I tried to get inside. The gate was swinging so extensively, there was no way I could open the gate. The road outside is paved with small tiles. There was a rattling sound as if a huge serpent is going underneath your feet. I think it was one of the most scariest moments of my life, man. I thought, I'm dead.
According to Hindu belief, earthquakes are part of the third stage of nature's dance: creation, preservation, dissolution. Of all the natural disasters, earthquakes are the most difficult to predict. We know they are inevitable, but we have no way of predicting them.
In the case of volcanoes, we know that there are warning signs that we can measure. For example, small seismic events that are produced when magma rises into the chamber. But for earthquakes, we don't know what the precursory signs are.
One thing is certain. The measurements gathered by Jean-Louis Meunier's team show that part of the energy stored between the two tectonic plates has not yet been released.
The earthquake this year was incomplete. We're sure about that because our studies show that one part shifted between the north of the mountains up to Kathmandu. But between Kathmandu and the plains, the overlapping part remained stuck.
So a second earthquake could relieve the tectonic strain with even more catastrophic results.
If we imagine that my hand represents the Indian plate, which is going under, here we have the mark showing the contact with the surface. So that's India, and that's what's underneath. And the earthquake that hit in 2015 was a fairly deep section. What still has to shift is this part, that comes from the part that broke up to the surface. And that's another 100 kilometers. We could expect another major earthquake with extremely destructive consequences.
Whether it's a question of months or years, nobody knows. The scientific community will be keeping a close eye on Nepal, fearing that a second quake is probable. Despite this alarming collection of catastrophes, has the final toll of natural disasters for 2015 been exceptional? Not necessarily, at least in terms of economics, according to Robert Muir Wood, who develops catastrophe models for insurance companies.
You can see what is the total cost worldwide of natural catastrophes. You can see by what the losses have been. It's probably around 100 billion euro of loss altogether, and it's of that kind of order. So you know, there is a significant amount of potential economic impact of catastrophes out there, just on an average year. So I mean, I don't know what it is this year so far. But I mean, I think it's actually quite a lot lower than average. So in places like Taiwan, there's quite a lot of insurance. So there's been insurance losses this year. There's very little insurance in Nepal, for example, because it's such a poor country. So this year, for insurance terms, it's being very quiet.
Volcanologists agree with this analysis. At this stage, despite some spectacular events, 2015 has not been particularly newsworthy.
It was relatively calm. It was the Calbuco eruption. There was this Bardabunga that was dying out. So it gave, I think, the scientists a little bit of time to try to understand the data they had acquired. It's a very good year when there is not too much going on.
Finally, in terms of cyclones, the year 2015 has been geographically sporadic. Globally, the number of tropical cyclones has remained stable, with around 80 storm systems per year. For the Atlantic Ocean, 2015 was particularly calm if we refer to the alphabetical system that is used to name hurricanes as they appear.
When there is an El Niño, in other words, warm temperature anomalies, in the east of the Pacific, cyclonic activity reduces in the Atlantic. For example, in 2005, a record-breaking year, we went all the way to Z, and then when we had used up all the letters, we started at alpha, beta, gamma, delta. And I think we were up to 31 named cyclones in 2005, which is an all-time record, because normally we have about 10 in the North Atlantic, so that gives you an idea. Today, we're at J, and in 2005 we had to start using Greek letters.
This apparent calm does not mean that scientists can lower their guard. The El Niño effect is far from over. It is not until Christmas 2015 that El Niño, named after the baby Jesus, reaches its full potential.
It's quite normal that we haven't yet seen any very dramatic climatic anomalies on a global scale. El Niño is still growing, and it won't be at its maximum until Christmas. At the beginning of 2015, we had a very weak temperature anomaly in the Pacific Ocean, and the growth period is only beginning now.
The potential consequences of El Niño will not be limited to the Pacific. This meteorological system is one of the most powerful forces that affects global climate.
It's not at all as localized as it seems from a European point of view. At the tropics, we have half the surface of the world that is located between 30 degrees north and 30 degrees south. And the Pacific Ocean is a real monster in terms of the world's oceans, because we have 17,000 kilometers of coast from South America to the Philippines at the other side.
Torrential rainfall, droughts, serious disruption could affect our planet in the upcoming months. Even thousands of kilometers from the area where the climatic abnormality began.
There'll be huge amounts of flooding along the coast of Peru and Bolivia, for example. There may be a drought in the northern part or the northeastern part of Brazil. So there are a lot of things which correlate very clearly with what happens when we have an El Niño. I mean, I think you tend to get a drought in Australia, for example. There are many things we can actually link to El Niño, many things we can expect to happen over the next few months.
The last record-breaking El Niño was in 1997-98, with a temperature rise of 2.7 degrees Celsius. The damage caused as a result was estimated at $33 billion. By the end of 2015, El Niño is already close to a 3-degree rise, allowing climatologists a glimpse into future major weather trends.
There's no doubt that 2015 and 16 will be record-breaking years in terms of heat. But on the other hand, 2017 will be a cold year, because after El Niño, there will be La Niña, which is a cooling down of the Pacific, so it swings back. But in terms of heat waves, if we look at heat waves in France, we are fairly sure that if we don't reduce current global warming, we will have more heat waves. At the moment, we have 2 or 3 days of heat waves per year in France. But in the future, we expect to have up to 20 or 30 days of heat waves per year. We're pretty sure of that. In terms of storms and precipitation, the research isn't advanced enough to say anything definite yet.
This scenario is still reversible on the condition that major political decisions are made to limit the level of greenhouse gases and to keep global warming in check. Despite a large number of natural disasters, 2015 has not been as unusual as we might imagine. Certain unexpected events, like the earthquake in Nepal, left deep wounds. Others, such as volcanic events that are easier to study, have more or less remained under control. In 2015, all the ingredients for an explosive year came together. A record-breaking El Niño, global warming, and the Pacific Decadal Oscillation combined to create extreme weather events. And it's not over yet. The dice are loaded. We can expect more severe weather patterns in 2016. In 2016 marked the end of one of the strongest El Niño events ever recorded. It triggered unprecedented floods in South America. Northern Europe witnessed heavy flooding too. But all that was to change several months later as the planet experienced the hottest August on record. Extreme droughts in several regions sparked massive wildfires. The high surface temperature of the oceans fueled severe storms in the Atlantic and the Pacific.
We had, for the first time in the Atlantic, 2 intense hurricanes at the same time that had not been seen before.
We can predict those storms, but we still can't foresee one of the planet's most lethal natural disasters: earthquakes.
We've seen a number of medium-sized disasters which may cost billions to tens of billions of dollars.
Using only professionally shot footage capturing the heart of the action, this film presents the major natural disasters of 2016, from the least deadly to the most dramatic. In the southern hemisphere, the climate provoked a catastrophe of unusual proportions in the capital city of Paraguay, Asunción, which lies on the banks of the Paraguay River. At the beginning of the year, torrential rainfall affected the river's catchment area in Paraguay and the surrounding countries. From late December, Heavy rains, driven by a strong El Niño, increased river levels in Paraguay, Argentina, Uruguay, and Brazil. But what exactly is El Niño?
The El Niño phenomenon, which owes its name to the period it normally arrives at, right around Christmas time, comes from the nickname of Jesus Christ in Spanish, El Niño.
This recurring phenomenon begins when warm water in the western tropical Pacific Ocean shifts eastward along the equator towards the coast of South America. During an El Niño, the Pacific's warmest surface waters sit offshore of northwestern South America.
The rising temperatures in the East Pacific move the rain from the east of the basin, so it creates rain anomalies and very rainy phenomena, with flooding on the east coast of South America.
In Asunción at the beginning of January, flooding forced over 150,000 people from their homes. Parts of Asunción had already been experiencing flooding since November. By mid-December, the levels of the Paraguay River had reached over 20 feet, the highest of the year at that time, and well above the 18 feet considered to be the critical stage. Many feared the worst. Thousands were evacuated from neighborhoods along the river as levels of the Paraguay rose to 26 feet on January 7th.
Every year, the flooding gets worse. It's a place where the river keeps getting bigger and higher, and recently it's been out of control. In December, I couldn't get here. Today, I made the effort to come for my father. You see, it's not easy to get to. It's an area that's very prone to flooding. And it gets worse and worse with the rain coming from Brazil and Argentina. It's hard because we have to make a lot of sacrifices. People always think that this time will be the last time, but it keeps on happening. History repeats itself. People start rebuilding, and almost before they finish, it starts again, and everything is washed away. My father has his whole life here, his animals, his family. He doesn't want to leave.
Around 6,000 families were affected in the first weeks of December. But when river levels jumped to over 23 feet, these numbers doubled. 13,000 families were hit by flooding, most of them from the poor Los Bañados area of the city, located close to the river. The government of Paraguay declared a state of emergency in Asunción and 7 other regions of the country similarly affected. El Niño events occur irregularly, roughly every 2 to 7 years, and last from 12 to 18 months, bringing with them risks of repeated flooding in vulnerable areas and the danger of outbreaks of cholera and malaria. At least 200 pylons were damaged in the rains, leaving thousands without electricity. And 4 people were killed by falling trees in what has been called the worst flooding in 50 years. The government immediately made $3.5 million available to help those who had been affected. As the climate changes and gets warmer, ocean temperatures also increase. And warm oceans fuel hurricanes and typhoons. In 2016, Taiwan was particularly badly hit by typhoons, just as new research pointed to the fact that the power of these destructive storms has increased by 50% over the past 40 years. The Pacific typhoon season started late in 2016, with the first named tropical storm, Typhoons, only developing on July 3rd. The storm began its life as an area of low pressure over the eastern Caroline Islands on June 30th. On July 5th, it was upgraded to typhoon status. By the end of the day, with sea temperatures over 30 degrees Celsius in the Philippine Sea, Typhoons was declared a super typhoon. It reached peak intensity near Taitung on the southeast coast of Taiwan, with wind pressure at 900 millibars and maximum sustained winds of 125 miles per hour. Typhoons crossed over Taiwan on July 7th.
Eastern side, it has big mountains, and not very many people live on the east. Almost all the activity, the economic activity, the big cities, almost all the people and the buildings are concentrated on the western side of the island, the lowland side of the island. And most typhoons, they come from the direction of the southeast, and so they tend to hit the mountains first.
Typhoons caused 3 deaths in Taiwan, but went on to cause 83 deaths in China, and a total of $1.5 billion worth of damage. 3 months later, a second typhoon hit Taiwan. Named Meranti, it was the strongest tropical cyclone worldwide in 2016, and one of the most intense tropical cyclones on record. The storm formed west of Guam in the western Pacific Ocean. On September 11th, it was upgraded to typhoon status, rapidly intensifying on September 12th and becoming a Category 5 super typhoon with maximum sustained wind speeds recorded at 150 miles per hour and a minimum barometric pressure of 890 millibars. Meranti clipped the southern end of Taiwan. Two people were killed, and over 700,000 homes lost water and electricity. The storm went on to destroy nearly 300 houses in the Philippines and kill some 30 people in flood-related events in China. On September 21st, again near Guam, a tropical depression formed, becoming Typhoon Meggy on September 23rd. The typhoon reached peak intensity as a Category 3 typhoon, this time over the island itself, making landfall at Hualien City on the Pacific east coast of Taiwan, with maximum sustained winds of 100 miles per hour and a barometric pressure of 940 millibars. Giant waves battered the coast as Meggy landed, leaving over 3 million households without power in the second worst blackout in the country's history. However, given the size of the waves, the damage was not nearly as bad as it could have been.
The last of these typhoons brought quite high wind speeds, so wind speeds that in most countries would have been quite damaging to Taiwan, in particular to the main port at Kaohsiung in Taiwan. It brought very high winds, but it didn't do a very large amount of damage because the buildings in Taiwan are quite well built.
As the storm's eye passed over the island, the winds changed direction. Meggy forced more than 14,000 people to evacuate to government shelters from mountainous areas near the coast. Even though Taiwan and southern China are well prepared for such events, 91 people died, and the total cost of these extremely destructive typhoons has been estimated at $1.25 billion. Researchers are warning that these giant storms will become even stronger in the future, threatening the large and growing coastal populations of Pacific nations. Other events are likely to become more devastating as a direct consequence of human population growth. 2016 illustrates the challenge of living on a tectonically active planet. The Pacific Ocean is circled by a network of tectonic fault lines and volcanoes known as the Ring of Fire. To the northwest of this ring are Honshu and Kyushu, Japan's most populated islands, which lie at the junction of several plates. The Philippine Plate collides with several Eurasian plates, creating a fault line that loops under the islands from southwest to east. At the extreme south of this zone, the Kumamoto district is built on layers of rock. Every year, dozens of tremors are felt in this area. In April 2016, a series of earthquakes hit the Kumamoto area, including a magnitude 7 main shock on April 16th. It was centered around 60 miles southeast of Sendai, close to the site of the devastating quake and tsunami that struck in March 2011.
These earthquakes in Kyushu, they weren't located on the subduction zone plate boundary. They were located on a zone where there's a lot of active faulting running down the middle of Kyushu.
Roads were damaged and thousands of homes were destroyed in the earthquake. Between the 14th and the 20th of April, the area experienced more than 600 aftershocks, including 2 very strong ones. 15,000 soldiers from the Japan Self-Defense Forces joined relief efforts.
The main priority we have at the moment is looking for people and saving them. And to be honest, it's been very frustrating, because we can't do anything at all for the moment. The aftershocks keep continuing. We need to be very careful because nature isn't making us feel very optimistic.
As well as destroying houses and buildings, the earthquakes triggered landslides across the Kyushu mountain range, leaving scars on the hillsides and forcing the collapse of the Great Aso Bridge into the Kurakawa River. This was an unprecedented event in the area's living memory.
We already had several large landslides 5 years ago. They were declared national disasters and they caused a lot of damage. I'm not sure if these ones are bigger compared to the ones we had previously, but they are ongoing. And huge rocks that had never moved before have fallen this time. You can see on the mountain areas that the soil is red as a result of landslides.
On April 17th, Japan's Prime Minister Shinzo Abe mobilized 3,000 personnel from the Air Force to help local authorities reach impacted areas.
I am part of one of the search and rescue teams. At the moment, we are looking for people who have disappeared. It is the first time that we have seen an earthquake and a landslide of this size. Since I arrived here, we have found 4 people. One person is still missing, so we are going to search all night. It is a natural occurrence, and nobody could see it coming. We have no warning. We don't know where the houses have been carried off. We are doing research based on assumptions.
Time is running out to find survivors. The team prepares for a sleepless night.
Three people in Yamaguchi. They haven't arrived yet?
They've already gone down there.
They've already gone down. And the last one? Our one? Okay, that's all. Now we'll go down. I'll lead the way.
Are we on the list?
2 people? Yes. You can come with us.
Dozens of people were pulled from the rubble in a desperate effort to find survivors before the forecast rains began. On April 18th, 24 people were found dead. 11 were still missing, and more than 91,000 had been evacuated. The number of people seeking shelter had risen to 180,000. As a result of the tremors, the entire city of Kumamoto was left without water. By April 19th, the continuing aftershocks drove even more local inhabitants to sleep in their cars, stadiums, and open spaces. Government officials estimate that more than 1,000 buildings have been seriously damaged, with 90 completely destroyed.
The epicenter of the first one was at Mashikimachi, and then the second earthquake was in the Aso region. When the second earthquake hit, the house collapsed. It happened at roughly 1:25 in the morning. It felt like my body was being thrown from one place to another over several feet. I was just there, where the table in the living room is, under the clock. I was sleeping under the table because I thought it would be safer and that it would protect me if something fell on top of me. That part was 2 stories high, and underneath there was the garage and my bedroom. It's terrifying to think what might have happened to me if I'd been in my bedroom at the bottom. The car was squashed like a pancake. For the last 5 years, once a year we have an earthquake of about 3 or 4 magnitude. I think it was a sign, a warning sign.
Although the focus of the earthquake was underneath Mount Kimpu, to the northwest of Kumamoto city center, the worst-hit areas were Mashiki and Mikubo, in the eastern suburbs. On the 21st of April, as feared, bad weather arrived, adding to the rescue team's difficulties. Rainwater runs into cracks, bringing with it the risk of provoking landslides on the unstable ground.
The cliff is slowly collapsing because of the rain. The inhabitants of the houses living below the cliff have all been ordered to evacuate the area. We are actually in the process of checking if everything has been taken care of.
Among the most exposed were the houses around Asso, where the active fault moved the ground 6 feet sideways on April 17th. The building's foundations are now anchored into land that the earthquake has turned to soup.
There's nothing we can do, faced with the power of nature.
I comfort myself with the thought that there was nothing I could have done about it. There are only 2 of us in the house. We're thinking about living with other people now, even in temporary housing for a short period. All the houses here were destroyed the second day. The first day, the road started to worsen. 3 pine trees and an electrical pylon fell on my house. My legs tremble with fear.
Around Asso, solid earth turned liquid, swallowing cars and roads, and even toppling buildings that had been resting on the weakened soil. This liquefaction has been the most destructive part of the disaster. Scientists have long tried to study the phenomenon, but now researchers say that many of their models are flawed and fail to accurately represent real-world conditions.
Liquefaction usually takes place in sandy soils. When the sand is mixed up during the tremor, the pressure means that the ground turns to liquid. That causes weaknesses in the ground, and the houses lean over, like that one behind us, because the ground can no longer support it. The ground here also has a particular geological feature, which is that it's covered with volcanic ash, which has built up on the sides of the mountain.
Amidst the turmoil and confusion, a team of Japanese seismologists is taking measures in an effort to establish a 3D model of the area affected. They are trying to understand the region's tectonics and the forces in motion.
If you look at this area over here, you can see that it has turned into a sort of staircase. The ground is very soft. I think that when large parts of the ground slipped, the surface kept on slipping, and it's not often you see a mountain collapse like that.
Japan is constantly under threat from new quakes and volcanic eruptions. The whole country is under the continual scrutiny of seismologists and volcanologists. 20% of the world's earthquakes hit Japan each year, around 600 per year. In 2016, another violent quake measuring 7.1 magnitude was felt on November 22nd in northern Japan, near Fukushima, causing more fear than harm. Altogether, the Kumamoto and other Japanese earthquakes of 2016 killed 49 people and caused an estimated $7.5 billion of damage. A few months after the Philippine tectonic plate made headlines in Japan, Another tectonic plate caused havoc in Italy. The Mediterranean basin is crushed by the African continent, moving under the Eurasian plate, which generates complex subduction faults. Trapped in the middle, the Adriatic plate rotates in an anti-clockwise direction at a rate of 1/10 of an inch per year around the city of Amatrice and the neighboring villages of the Apennine mountain range in central Italy. The isolated mountain villages are known for their olive oil, black truffles, and vineyards. At 3:30 a.m. on August 24th, a shallow but strong earthquake measuring 6.2 magnitude took the villages by surprise. The towns of Arquata, Pretare, and Pescara del Tronto, among others in the region, were badly damaged. Local priest Francesco Armandi is the living memory of these villages.
On
the night of the 24th of August, at 3:36 to be precise, we heard a loud crash and the ground shook violently. I was in bed, but I was awake, and we had the impression that nature was trying to make my bed hit the ceiling. I waited until the end of the quake, and I got dressed quickly and went out. The streets were full of rubble, stones, and big rocks. The whole population was in the street.
I got up, I put my slippers on and got my son, and even before the first quake was over, we were already on the staircase. At the bottom, we realized that we were in our pajamas at 3 o'clock in the morning. When the second tremor hit, we heard the Mount Vittori. It made a terrible noise. At that moment, everything crumbled. I said to myself, Mamma mia.
Not only that, we were just in the car park next door when we heard a noise of stones from the summit of Vittor that were rolling down with the tremor from the earthquake.
In 10 minutes, you look around you and you see the disaster. My house is still standing, but you can't live in it. It's as though everything has come to an end. And looking at your village that no longer exists is even harder. The school bus arrives here. I've picked my son up here lots of times. I would give him his snack. We'd go to the bakery. That was our life. Simple, basic, but it was our life. It's gone now. I'm sorry.
In addition to the loss of human life, some of Italy's important cultural heritage was also destroyed.
A church collapsed at Pescara. It must have been 1,000 years old, and it's never collapsed before, even though there have been other earthquakes, which must mean that this one was much stronger.
These are not the colossal tremors we see at tectonic plate boundaries, where events occur measuring 8 or 9 magnitude. The effects in this region are devastating because the quakes take place near the surface of the crust. These small faults are shallow, causing dramatic shaking above the site of the quake.
The truth is, we're just one little dot on the geographical map. In fact, we're just one little star. On the Italian Geophysical Institute site, they mark the epicenter with a star.
Over 4,000 people were involved in the search and rescue operations, and 238 victims were pulled alive from the rubble by the timely intervention of the authorities. Earthquakes are like bullets in a game of Russian roulette. One can never be sure when and where they will unleash their destructive power.
We realized that it was a miracle. Because at Pretari, apart from the damage you can see behind us, nobody died, nobody was injured. Then we saw Pescara. We rolled up our sleeves and we said, we're still here, we can do something. But what happened in Pescara was unbelievable.
Unfortunately, the village was completely destroyed. In fact, if you go, you will find just a pile of ruins. There are about 50 deaths. These were people I knew. I had married them, baptized their children. So I'm also shocked, because when 20, 30, 40 or 50 friends die, there is a lot of internal struggle and lasting pain. We will certainly have difficulty pulling ourselves together to start again. I lived through the earthquakes in 1972, in 1997, and the one in Aquila that we felt here because we are fairly close. But for me, they weren't as strong as this one. This time, it seems the earthquake followed a line, a cursed line. Like Pescara, totally destroyed. But next to it, the village of Vezzano, which is less than half a mile away, was spared completely. Nothing collapsed. So these are phenomena that I, for one, can't understand.
Can science explain such bizarre phenomena?
The mountains are splitting apart, and you've had a succession of earthquakes running from south to north, one after the other, weeks and months apart, as this set of faults, very well-known faults you can go out and see running across the mountainsides in this region, which have had big earthquakes on them in the past hundreds of years. These faults have been breaking one by one, rupturing further north along the main axis of the Apennine Mountains in Italy.
This is neither the first nor the last time that Italy will experience a big earthquake. Between October 26th and November 3rd, a series of 10 shallow earthquakes ranging from 4.5 to 6.5 magnitude hit the area of Macerata. They occurred on an active fault between the area hit by August's earthquakes and Umbria, which suffered in 1997. The process of faulting and destruction continues. 298 people lost their lives in the August earthquake. The total cost of destruction has been estimated at $2.6 billion. The Pacific Ocean, the largest and deepest ocean in the world, conceals a network of faults caused by plate tectonics. Particularly in the west, where the immense Nazca Plate moves under the South American continent at a speed of more than 2 inches a year. In Ecuador, 60% of the 16 million inhabitants live in coastal areas, including the country's largest city, Guayaquil. At 7 p.m. on April 16th, the earth rumbled and many cities lost power. It was only at daylight that the government realized the breadth of the destruction caused by this tremor. The earthquake took place in early evening, with the towns of Portoviejo, Pedernales, Manta, and Canoa among the worst affected. But the fact that the earthquake occurred at the end of the day, before people were sleeping, meant that there were fewer victims than there might have been. It was measured at 7.8 magnitude, the strongest earthquake to strike in 2016, and the largest earthquake to hit Ecuador since 1979. President Rafael Correa declared a state of emergency. 13,500 military personnel, police officers, and firemen were brought in to deal with the situation.
I am the person responsible for the zone that was the worst hit. It's a shopping area that was in full swing when the tragedy happened. The rescuers arrived at all the critical points. For the first 2 hours, the firemen spread out over the whole zone and managed to save victims. There were a lot of survivors. Then we had to look out for the dead bodies.
More than 600 people were killed in the provinces of Manabí and Esmeraldas, and over 6,000 were injured.
The earthquake happened at a time that, thank the Lord, saved lives. People were still working, they were in the streets. If it had happened an hour later or very early in the morning, it would have been much more complicated. There would have been much more loss of life.
It felt like somebody picked my house up and threw it on 40-foot seas, and it was going all over the place, you know, front and back and side to side.
The wave arrived when I was at home, and I saw how the mountain could lift itself up. I also saw some of the buildings in town move. I saw the houses opposite rise up, collapse, and rise up again.
Pedernales sits right next to the plate junction. This town of 40,000 inhabitants was particularly badly hit. Many of the town's buildings were completely destroyed.
Our house is made up of 5 floors. By the time the aftershocks had stopped, as you can see, it was a big house. 5 members of my family died in it. My sister, who is 17 years old, is still psychologically affected. She's really struggling because she saw the whole building collapse. And my mother saw the 6-story building behind me collapse. It all just fell at once. It was completely destroyed.
Some 30,000 people were made homeless. Water, gas, and electricity were cut in many parts of the region, and hundreds of miles of roads were destroyed. Many people's livelihoods have been severely affected.
The pain will always be there. Years of work, loss of hair, white hair. Everything is gone. Nothing is left. 20 years of my life. We started with a small property, a bit further away, over there. And then we moved and came here, after many efforts and sacrifices. We were in debt for 18 years to pay for this construction. We just can't mess around with physics. The structure is twisted between the 3rd and 4th floor.
People were in shock. Everybody was sitting there watching. I was too. I felt shell-shocked. You know, I was just sitting there and couldn't imagine how something like this could happen. But in the weeks since, it feels like we've got help. We're starting to get some support in the community, some coordination. You know, that's the biggest thing, is trying to coordinate everybody's efforts so we can get this place back on its feet again. Businesses are starting to open, which has been great. People are starting to rebuild their houses, which is great. But we're trying to work with the local government to make sure the building standards are where they need to be so something like this doesn't happen again.
Ecuador, Bahia, and the whole region is a very active seismic zone. Throughout history, we've had seismic periods, and it's not over yet, and it's not going to change.
The depth and precise area hit by the April earthquake are typical of those in a subduction zone between two large-sized plates. Such mechanisms produce the most intense earthquakes known, and where the Earth has shaken, it will inevitably shake again, either nearby or at exactly the same spot. The most recent buildings sustained little damage. Those that fell short of earthquake-resistant standards were destroyed, causing 673 deaths and damage worth $3.3 billion. Low construction standards of poor countries have been responsible for many casualties on the other side of the American continent. The rain brought by the arrival of the West African monsoon is vitally important for African farmers. This monsoon also heralds the arrival of what are known as tropical waves, at the origin of many Atlantic tropical storms. One such wave, which was to become Hurricane Matthew, left the west coast of Africa on September the 22nd. With environmental conditions favoring slow development and thunderstorm activity increasing, the tropical wave proceeded westward across the Atlantic Ocean. Matthew developed into a tropical storm 35 miles southeast of St. Lucia on September the 28th. The storm became a hurricane 190 miles northeast of Curacao on September the 29th, achieving Category 5 intensity the following day at the lowest latitude ever recorded for a hurricane of this intensity in the Atlantic Basin.
Hurricane Matthew started moving north and moved north quite slowly.
Where it would make landfall remained a mystery. Cuba, Haiti, and Jamaica felt the humid breath of this monster and put coastal areas on red alert. At 7 a.m. on October 4th, Hurricane Matthew hit Haiti with winds of 145 miles per hour, becoming the country's first Category 4 storm since Hurricane Cleo in 1964. Despite preparations, the damage and loss of life on the island were catastrophic. More than 1,000 people were reported killed in the aftermath of Hurricane Matthew, as hundreds of thousands of homes were destroyed. More than 1 million people were left in need of humanitarian aid, with damage estimated at nearly $2 billion. After ransacking Haiti, the hurricane headed towards Cuba. At 8 p.m. on October the 4th, Matthew made landfall near Huauco, with winds of 140 miles per hour. Land interaction with Cuba helped to weaken the storm to a Category 3, though Matthew eventually re-attained Category 4 intensity as it moved away from Cuba and towards the Bahamas. On the 5th of October, Matthew made its third landfall over Grand Bahama as a Category 4 cyclone. Preparations began in earnest across southeastern United States as Matthew approached, with several regions declaring a state of emergency for coastal areas. Widespread evacuations were ordered for large parts of the coast. The storm paralleled the southeast coast of the United States over the next 36 hours, gradually weakening while remaining just offshore, before making its fourth and final landfall in South Carolina on the morning of October the 8th as a Category 1 hurricane. Damage was primarily confined to the coasts of Florida and Georgia. but 47 people died in the U.S. in Hurricane Matthew. On October the 9th, Matthew returned to the Atlantic, becoming an extratropical cyclone as it turned away from Cape Hatteras, North Carolina.
It's like a story which captures everything from the poorest to the richest, because it hit the poorest country in the region in Haiti, caused huge amounts of damage and loss of life, but then kept moving north. If the track had been 100 kilometers further to the west, there would have been a huge amount of damage in Florida from Matthew. But by the time it did make landfall in the US, it had weakened, and so it was more a flood event than a wind event. So the US was fantastically lucky with Matthew. Haiti was fantastically unlucky.
Over 1,500 deaths have been attributed to Hurricane Matthew across the western Atlantic. And with the storm causing damage estimated in excess of $8 billion, it was also the costliest Atlantic hurricane since Hurricane Sandy in 2012. Not all countries are affected by natural disasters in the same way.
There are big differences between the first world, between the developed world, where most of insurance is written in richer countries. People tend to build stronger buildings, better buildings. They tend to follow the rules, the code in how they build those structures. If you're working in developing countries, you may tend to find a lot more risk that things are not built so strongly. There's more building in the path of floods, for example. There's less protection for people. And so there are very different challenges if you're modeling risk in the first world to if you're thinking about risk in the third world or the developing world, where the consequences of disasters can be much more critical to people's lives.
2016 has had its share of disasters. Fires, earthquakes, storms, droughts, flooding. But what percentage of these events can be attributed to global warming?
We now have techniques in order to identify what is the cause. It's called attribution studies. So it's done at a number of universities now, where you run the world's climate since 1950 in one version of the Earth where you have the increase in greenhouse gases year by year, and another version of the Earth where there's been no increase in greenhouse gases year by year. And then you run these two versions of the Earth to discover how likely a particular extreme, it could be an extreme drought, it could be extreme rainfall, how likely that is in these two worlds. And that tells you how much climate change, how much global warming is influencing the occurrence of the extremes.
One thing we know for sure is that natural disasters hit the poor much harder than the rich. If it can be recognized that global warming is responsible for at least some of the disasters our living planet creates, then we can realize the urgency of approving climate policies that protect vulnerable populations.